Hello everyone, welcome back. I am Fer, and this video, like all my videos past, present and future, is brought to you by my Patreons, Otimotiosum, Matt Zweig, Daniel H. McGillivray, Marlo Brown and Valerie Hyde. All my Patreons, thanks a million times, thanks a thousand times, thanks a million times. One of the pillars of Magic the Gathering is the 5 colors of mana. They serve to symbolize different things you can do with magic, but also different ideologies and different worldviews. But one of the things that interests me the most about magic is that in universe it is treated like energy. For example, you can have devices that store mana and that give you more mana, and you can have devices that take mana of one color and turn it into mana of other colors. But this is not surprising, because actually one of the original inspirations for Magic the Gathering was the book The Magic Goes Away by Larry Niven, shown here with its extremely aggressively 80s cover. In this book, Larry Niven imagines a world in which magic is some kind of energy that allows you to do certain things, and the problem is that the people in this world are running out of this kind of energy. This might sound very weird for a fantasy novel, but what happens is that Larry Niven is actually a science fiction writer. One of his most famous books is Ringworld, and actually he was a consultant for Halo Combat Evolved. Did you guys know that? I didn't. And in fact, he was later honored in the story with the creation of this character called Nevi Neural, which is just Larry Niven but backwards. What I'm going to do in this video is continue this chain of having this fantasy world heavily inspired by magic, and I'm going to use particle physics to explain how the magic in Magic the Gathering works, with math and everything. Are you ready? Let's go! Let's start with one thing that everyone agrees that no one understands: spin. And if you want to know why spin is so confusing, I suggest you check out this episode of PBS Spacetime. It's really good. And okay, if you understand how anime death works, or if you understand banding, this shouldn't be too much of a problem. But okay, let's start with something that everyone knows: the Earth. Okay, so this is the Earth, and as you know, it is spinning around its axis of rotation. At some point, mathematicians figured that it was really useful if we represented this axis of rotation as an arrow. And if this arrow was pointing up, that would mean that it was spinning to the right. And if we had an object whose axis of rotation was an arrow pointing down, well, that would mean that it was spinning to the left. And this is just a way to represent it. It's just a way to represent different kinds of rotations in a very simple manner, with just arrows pointing up and arrows pointing down. Okay? But then it turns out that you can treat these arrows as vectors, as just arrows pointing in space. And that's really useful, because you know that, for example, this is an arrow that is pointing to this point in space. And it is just telling you that to reach this point, I have a white color, that to reach this point in space, well, first you have to move this much in this direction, then this much in this direction, and finally this much in this direction. And then you get there. These are the components. The problem with spin starts when you consider quantum mechanics. Another useful thing about representing rotation in this way is that you can take the length of the vector to represent how much something is rotating. So for example, let's say that this has a length of 2. Well, then it is spinning twice as faster at something that had just a length of 1, like, I don't know, this one, for example. Everything is very nice up to this point, but then quantum mechanics comes into the mix and makes everything very complex. Because let's say that we have a particle, an electron, and it is spinning, and it has a total spin of 1/2. Then if we try to measure the spin of this electron, well, what we do is we put some kind of magnetic field, and here is the electron, and so we have our field, and we want to measure how much the spin of this electron aligns to the magnetic field, and it sounds very complex. The point is that we have to measure spin in one direction, right? You just choose one direction and you say, hey, how much of the spin of this particle lines up with our direction of measurement? Let's say it's this one. Well, we call that value as C or as Z or however you want to call it, and turns out that, at least for electrons, it's always going to be exactly the opposite of our direction of measurement, or exactly the same as our direction of measurement. And that's very weird. It's like exactly, it's never a variation, that's exactly its value, always. And what happens is that if you have a particle, any particle, let's say that you had a particle with spin 2, for example, and then you measure that, well, then the possible measurements you could get are -2, -1, 0, 1, and 2. And yeah, it sounds very weird. If you're not familiar with quantum mechanics, you might be thinking like, hey, why cannot I have like 1.2 or -0.7 or like 3? I don't know. But turns out, no, we checked. This is how it works. The momentum of a particle, the spin of a particle with total spin L goes from -L to L in steps of 1. So for example, in the case of the electron, if the total spin was 1/2, then -1/2 plus 1 equals 1/2. And this is why these are the only two states of spin the electron will have. But check this out. With 2, we have 5 possible states. And we have 5 colors of magic, in Magic the Gathering. Well, 5 colors of mana. So this is gonna be relevant, just keep it in mind. Keep it in mind as we consider the particles that make the universe. Because as far as we know, this is everything that the universe is made of. Okay? Just quarks and leptons and bosons. Up, down, strange, charm, top, bottom. If you don't know what a quark is, doesn't matter, just still got it. I really like this song. And you might be thinking like, well, why is this particle called up and this down, or top and bottom? Well, turns out that at some point, scientists thought that maybe they were like spin. Maybe this particle was really pointing up, and this one was really pointing down. But not in real space, mind you. Imagine like there was some kind of magical space. That we cannot access. But like if you had magical powers, you could reach into this space and you would find objects either aligned up or aligned down. And then you could switch them. And then when you did, you would find that they had changed in the real world. So basically the idea was that maybe these two particles were actually just one particle. And that in some magical space, when this thing was pointing up, it was the up quark. And that when it was pointing down in this magical space, it was the down quark. Now, later, it turned out that the reality was more complex than that. If you know about electroweak unification, you know what I'm talking about. But the point is that, yeah, in a way, all of these pairs of particles are just one particle in two different states. And so, what if something similar is happening with mana in Magic the Gathering? What if there is only one particle of mana, let's call it the sparkle, and then this sparkle it can have 5 different states in this magical space. And for example, when it has a spin of -2, well, maybe it is white mana. And when it has -1, it could be green, 0 could be red, 1 could be black, and 2 could be blue. Now, if that was the case, how would that look like? Like, how would these particles with these different values of spin interact among each other? Well, we can know that thanks to Feynman diagrams. Feynman diagrams are like ancient arcane runes that when you etch them, they can tell you the secrets of the universe. So, for example, here we have an electron interacting with a proton. And what they do is that they exchange energy between them, and this energy makes them change directions. And the particle that is aiding them in transferring this energy is this one, which we called a photon. So yeah, this is just light. Okay, we can do something similar for our sparkles. Let's say that we have a white sparkle and a red sparkle. Remember that the white sparkle has a spin in this magical space of -2. So then what could happen is that, remember, spin always changes by amounts of 1 or -1, and there's no other option. So the spin of these two particles will change by exactly 1. This means that the white will go 1 up, and it will become green, and the red will go 1 down, and also become green. This could be how the signets or other mana rocks take mana of one color and then turn it into mana of other colors. But check this out. Count how much was the spin at the start. At the start we had -2 and 0. So the total spin was -2. And then we have -1 and -1. So the total spin is still -2. The color changed, but the spin was conserved. That's actually really cool. However, there's a bit of an issue here. Notice how this is the only thing that could have possibly happened. The white sparkle could not go any lower. There is no state for -3 spin. It's simply not allowed for this kind of particle. And so the only option the white sparkle had was to send -1 of its spin to the red sparkle. And so the red sparkle had no option but to absorb it and become a green sparkle. Let's see another example so you see what I mean. Let's say that again we have a red sparkle, okay? And its spin is 0, and it is interacting with a blue sparkle with spin 2. Well, what's going to happen? Well, the blue sparkle cannot absorb any more spin because the state for spin 3 simply doesn't exist. The only possibility for this sparkle is to go lower and become a black sparkle. Okay, so this is a black with spin 1. And if this became a black with spin 1, that means that it had to release +1 of its spin to be absorbed by the red sparkle. And then the red sparkle went 1 up and then also became a black sparkle. But then notice how the problem is here, that white sparkles can only ever become green and blue sparkles can only ever become black. And well, the reds and the greens and the blacks, they have 2 options each, but there is no way for a green sparkle to ever become blue. There is no way for a black sparkle to ever become white. So yeah, they are locked into interacting with their closest partner. And I mean, this is cool, don't get me wrong, this is cool, but this is not how we see magic interacting in Magic the Gathering. We have seen the 10 Guilds of Ravnica, we have seen the Khans of Tarkir and the Dragons, we have seen many examples of factions that show that it is possible to combine all the colors of Magic in any combination that you want, and using spin simply does not allow that. Oh, and I almost forgot! What about colorless? How would colorless mana fit into all of this? Because even having 0 spin is already a color. And even if we somehow expanded this to have 6 different possible spin states, we still have the same problem, that they can only interact with the states that are next to them and not with the other ones. So yeah, this is not how magic in the Magic the Universe multiverse works. But lucky for you, I spent many nights in a wizard tower reading ancient lore books, and I learned the secret arts of quantum chromodynamics, and they revealed me the secrets that can make magic real. So this is how it works. They discovered that particles like protons were actually made of other tinier particles, which they called quarks. And so, for example, 3 quarks are needed to make a proton. And in fact, yeah, neutrons are also made of 3 quarks. They started studying how these quarks interacted with each other, and what they found is that they had something similar to electric charge. But while electric charge can be negative or positive, This kind of charge seemed to have three possibilities, which they called green, blue, and red. And this is how it works. They discovered that, for example, if they had a green charge, it would attract the charges of other colors, but it would repel all the charges of the same color. And so here in this example, this is green, but the same is true for red and blue. They both repel what is the same and they attract what is different. And even more, when they are together, they seem to cancel each other out. And the maths of these were really difficult to figure out, but once they did, it turned out to be a very beautiful mathematical structure, which mathematicians knew for a very long time, and is called SU3. Or is actually, well, the full name is the Special Group of Unitary Matrices of Order 3. But you can call it just SU3. I mean, we are all friends here, right? So now let's see how this force actually works. Let's say that we have a red particle interacting with a blue particle. What happens is that the red particle can send away its redness, and the blue particle sends away its blueness. And its blueness is absorbed by the first quark and it becomes blue. And then the second quark absorbs the redness of the other, and remember it had already lost its blueness, so it became red. And yeah, it sounds very weird, but that's kind of how it works, except for this thing in between. Remember that the electrons and the protons send each other photons to exchange energy. Well, this particle in the middle here is called a gluon. And you might be asking, well, why isn't just two gluons, one red and one blue? Because what happens is that the gluon moved in two directions at the same time. And it also didn't move. And it also wasn't sent by any of the particles, but it was also sent and received by both of them. It was always there and it was never there. It is everything and nothing. And if you can hold the infinity in your hand and be the lord of time. So the point is that the gluon can have either positive redness and negative blueness, if you imagine it moving in this direction, or it could be the opposite. It could have negative redness and positive blueness. So for example, it would be like you have this blue particle that received a gluon that had positive redness and negative blueness. So then the blueness cancel each other out and only the redness remained. And in a similar manner, you have here a red gluon. No, sorry, you had a red particle that liberated a gluon with negative redness, so they cancel each other out. And you ended up with minus anti-blueness, leaving you with only blueness. Yeah, so it's very weird, but I also see it like very mystical anyway. So that's how chromodynamics works. And it sounds crazy and like magic, but remember, this is the part of the video that's actually real, that this is actually science. And there's even another possible interaction. I mean, what if we had a quark with red charge that interacts with another quark with blue charge, and after interaction they didn't change colors, they are the same color they were at the beginning? Well, this could be achieved in several ways by gluons that have color, but it could also be achieved very easy by a colorless gluon. Keep that in mind. Now, you're probably wondering why, if I'm telling the truth, have you never in your life interacted with anything with red or blue charge or green charge for that matter? Well, it is because this force was confined. This is one of the deepest secrets I learned in the ancient lore books. The 8 gluons and the forbidden gluon. Okay, so remember how we saw that gluons had to be something like carrying red and anti-blue, or blue and anti-red, and that sort of stuff? Well, turns out we can use that to know what are all the possible gluons that could possibly exist. And turns out that there are just 8 of them. And here they are. And yeah, I know this looks very weird, like why are there plus sign here? Why is there a minus sign here? Why is there an imaginary number here? And why are there square roots all over the place? This is something that I cannot prove to you right now, it would be very long, so you just have to take my word for it, I guess. Although if you know group theory, this probably can make sense to you if you look at it hard enough and you pray to the right God. But the point also is that because these are the only gluons that exist, this also means that it is impossible to interact with anything that interact with this kind of charge unless you have charge. For example, this one, the gluon number 4. It is about something with red charge and green charge interacting together. This means that if you don't have any of these charges, you cannot interact with a strong force. And the same is true for each one of these gluons. They require the objects in question to have color charge in order to interact with them. But remember that if you have red and green and blue charge, it's actually like if you didn't have anything. And your protons are made of 3 quarks. It turns out that they also have 1 quark of each color. And so all protons and all neutrons have a color charge of 0. And for that reason, they cannot interact with any of these 8 gluons. Now, there is another one, the 9th gluon, the forbidden gluon. If this, let's look at this gluon more closely. Red and anti-red, so this is nothing. Blue and anti-blue, again, this is 0. And green and anti-red, this is again 0. This is like a 0. But this is like a 0 that exists. It's like a nothing with identity, a nothing that occupies space. It is the nothing and everything. It is infinite anyway. And one can start getting very zen and very mystical about these things. But the point is that if this gluon existed, then sure, protons, neutrons, and everything else would be able to interact with the strong force. But apparently it doesn't exist. And we looked everywhere. We looked under the table, and we looked beside the bed, and we looked in the sock drawer, and I looked in my pockets, and I looked even behind the fridge. It's not there. It simply doesn't exist. And that's something really nice about physics. You can say something like, I've looked really hard and I have not found it. Ergo, it doesn't exist. But mathematicians are not like that. Mathematicians would never accept that. They wouldn't care that you would be like, but I looked everywhere. I looked even inside my socks and even inside my shoes. And mathematicians would not believe you. But physicists are like, really? You looked even behind the fridge? And you're like, yeah. And then the other physicists like, well, I guess it doesn't exist then. And then you all go to the pub right in front of the university and you talk about Shaman King and Teen Titans all day while you drink beer. It's very fun. Anyway, the point is that the 9th gluon doesn't exist. But now we finally arrive at why this is relevant for Magic the Gathering. The mathematical structure we were using before was SU3. And SU3 has 3 square components minus the forbidden gluon, that's 8. So that means that if we want to make something similar, but with 5 colors, 5 different charges, then we would have 5 square, 25 different, I don't know, sparkles. Let's call them sparkles. Before I was calling sparkles the particles that have for example, before I was saying that these ones were the sparkles when we were considering the spin, but now we are saying that these ones are the sparkles, right? This is another formalism, and this might make it confusing, but at this point I don't care. I just want to finish the video, you know? So this means that, yeah, I have to do something like this, but for the 25 possible different ways that particles could change color. And guess what? I did. These are all the 25 possible sparkles that could exist in an SU5 symmetry. And yeah, we even have a 25 sparkle, which is the equivalent to the forbidden gluon. But the difference in this case is that, well, we have no reason to say that this doesn't exist. Because in the Magic the Gathering universe, well, multiverse, magic moves all over the place. It moves from and between the ley lines, and you can use it. It has a very long range. And yeah, you can even have and you can even have magic interacting with objects that didn't have magic before, which is pretty much essential if you want to enchant anything. And so, yeah, this means that in the Magic the Gathering universe, magic is a kind of force, and it has 5 different charges, one for every color, and these charges are interchanged between particles using one of the 25 possible sparkles that could possibly exist, even the one that is forbidden in chromodynamics. And yeah, this allows for this force to be unbounded, to interact with anything, even with things that don't have magic. Yeah, you can have magical things interacting with things that don't have magic, because you can use the 25 sparkle. And yeah, that's it. It feels kind of anticlimactic. How do you say anyway? But I enjoyed making this video nonetheless, and I hope you enjoyed it. And I hope you understood. I know this is very complex. I don't know. But yeah, the whole point of the video is that sometimes using magic can help you to understand science better, and sometimes science can also be very mystical, you know?